We don't talk about it, but patents even changed how we poop. From medieval cesspits to zero-gravity toilets, this is the flush-by-flush evolution of civilization. If you want to understand how a society really works, follow the pipes. The humble toilet, every day, invisible until it breaks, has been at the center of engineering breakthroughs for centuries. It's about more than comfort. It's about public health, urban design, chemistry, airflow, water pressure, and yes, the art of not smelling like a 14th century alleyway. Today, we're taking a tour from Privies over pits to the first water closets, through the age of sewers and siphons, into specialized systems for trains, planes, and off-grid cabins, and right up to smart seats and space toilets that need fans to do what gravity can't. Along the way, we'll see how a few clever mechanisms, some famously simple, others delightfully over-engineered, made all the difference. Quick question before we dive in. If you had to pick one, which toilet innovation would you keep forever? An S-trap that blocks odors, a quiet siphon-jet flush, a vacuum toilet that never clogs, a composting throne that works off-grid, a heated bidet seat that does everything, or the space toilet's airflow funnel? Tell me your pick and why. I'm genuinely curious which camp you're in. Privies to water closets, Harington's idea and Cumming's S-trap. Let's start where most people didn't want to look, down a hole. For centuries, the toilet was a wooden seat over a cesspit. In castles and cities, waste dropped through chutes or into pits that were emptied occasionally. It wasn't elegant, and it definitely wasn't sanitary. Smell was a fact of life. Then came a leap. In 1596, Sir John Harington, courtier, wordsmith, classic overachiever, designed a flushing water closet. Think cistern above, pan below, a valve to release a rush of water. It was more demonstration than mass product, but the idea was there. Water could carry waste away. The missing piece? A reliable way to keep sewer air from coming back up. That puzzle lingered until 1775, when Alexander Cumming secured a British patent for an S-shaped bend in the drain pipe under the bowl. That curved section always left filled with a little water. Blocked the return of foul air from the soil pipe. In plain terms, he created a water seal. Now the bowl could connect to a drain without your nostrils regretting it. Cumming's configuration was elegant because it solved multiple problems at once. It kept a standing column of water in the bend to form a seal against gases. The geometry let flush water sweep past with enough momentum to clear waste, but still leave some water behind in the curve. No moving parts in the seal itself. It just sat there and worked. You can picture why that mattered. Before, inventors tried flat valves and stoppers under the seat. Those could leak or stick. A water seal was passive and reliable, assuming the bowl and trap were shaped to avoid siphoning all the water out during a flush. If you've ever heard the term S-trap or U-bend, that legacy traces back to Cumming's move. A few years later, Joseph Bramah refined the water closet with better valves and improved cistern control, making household installations more trustworthy and less splashy. But the star was the water seal trap. It turned a smelly curiosity into a viable indoor appliance. It's worth pointing out how disruptive this was culturally. Indoors changed. Bedrooms with attached closets, actual water closets, became aspirational. The bacteria didn't care about fashion, but the adoption curve did. A system that didn't stink stood a chance. Sewerage, siphon-jet bowls, venting, and mass sanitation. Cumming's S-trap solved odor. The 19th century had a different monster, cities booming with people and waste. London famously learned this the hard way in the Great Stink of 1858. When your river is your sewer, hot weather is not your friend. The engineering answer was epic. Build modern sewers and standardize fixtures. As sewers spread, toilets had to evolve from boutique contraptions into dependable, standardized, code-compliant machines. 3 threads intertwined. First, the bowl. Early water closets came in washout and wash-down styles. They worked, but could be noisy and splashy. By the late 19th and early 20th centuries, designers perfected the siphonic bowl and the Siphon-jet bowl. Both rely on forming a siphon in the trapway to pull waste through quietly. The Siphon-jet version adds a dedicated jet port near the bottom of the bowl that shoots water directly into the trapway, rapidly starting the siphon. You get a gentle, rising swirl, then a smooth whoosh, no waterfall roar. What's clever here is the choreography. The rim channels rinse the bowl. A portion of the flush volume feeds the jet, priming the siphon. As the water level rises and then drops, the geometry sustains the siphon just long enough to transport the contents. Then, air breaks the siphon and the trap refills to re-establish the water seal. It's a fluid dynamics ballet, timed with nothing but ceramic contours and gravity. Second, venting and traps. Plumbers learned a painful lesson. Unvented S-traps can self-siphon when a big flood of water rushes past in the drain, literally sucking the water seal out. The fix was code-mandated vent pipes and the now universal P-trap under sinks and many fixtures, which holds a water seal but is less prone to self-siphon when properly vented. In essence, you keep the gas barrier but add a pressure equalizer, the vent, so flushing one fixture doesn't pull the seal out of another. Those vent stacks and branch vents made bathrooms safer and predictable. It's not glamorous, but the no sewer gas indoors rule is the skeleton key of modern plumbing. Third, manufacturability and hygiene. Ceramic technology improved dramatically. Thomas Twyford popularized all-ceramic, one-piece designs in the 1880s, eliminating wood housings and hidden crevices. Smooth, glazed channels reduced biofilm and made cleaning easier. Public installations took off after George Jennings' penny-in-the-slot flush toilets at London's 1851 Great Exhibition. When you can wipe down a surface and trust the mechanism underneath, you can serve crowds without inviting a public health crisis. By the early 20th century, toilet bowls were standardized marvels. Inside the ceramic, they were machines, hidden jets, tuned trapways, measured flush volumes. Outside, they looked serene. If you've ever marveled at how a good toilet is both quiet and thorough, that's a century of iteration solving for humans, water, and the occasional Ledo. Specialized systems, vacuum, off-grid, smart seats, and space. Once the world had a playbook, track the smell, feed the siphon, vent the system, engineers started asking, what if we can't use much water? What if there's no sewer? What if we're flying at 38,000 feet or floating over the Pacific in orbit? Let's start with trains and planes. Early rail toilets earned the nickname hopper for a reason. They were a hole with a flap, often dumping straight to the tracks. Fine at 50 miles per hour in the countryside, not so fine in a station. As regulations tightened and public expectations rose, railways adopted retention tanks and vacuum systems. The principle is neat. A small flush introduces a bit of liquid to wet the bowl. A valve opens momentarily to a vacuum line connected to a holding tank. Pressure differential, not a big column of water, pulls contents away. The bowl doesn't need a deep water seal because the valve and the vacuum piping isolate odors, and a little water remains as a seal between uses. With few liters per flush, You can run a whole train before emptying the tank. Aircraft adapted a similar approach. You've heard the rumor that airplane toilets dump straight into the sky. They don't. A vacuum-assisted flush opens a valve to a sealed tank, and the pressure drop does the work in a second or two. The bowl lining is slick, the water dose is tiny, and the system is built to avoid aerosolizing anything it shouldn't. The biggest innovation isn't the whoosh. It's actually the valve reliability and the seals. They must open and close flawlessly across wild temperature and pressure swings. That's where patent literature is full of clever seats, elastomers, and linkage designs you never knew needed so much thought. Now, head the opposite direction, off-grid. Composting toilets and incinerating toilets solve the no sewer problem differently. A composting toilet separates liquids and solids. A sloped bin or drum maintains a bulking material like wood shavings. Airflow, and sometimes a small heater, keeps conditions aerobic, so microbes do their thing. The key design elements are air paths, moisture control, and a way to agitate or tumble the pile so it doesn't compact and go anaerobic. These systems shine where water is precious and falling it away is impractical. Incinerating toilets take a very different path. They use electricity or fuel to burn waste into sterile ash. That means robust combustion chambers lined with high-temperature materials, sealed lids with interlocks, and smart control to avoid smoky starts or heat spikes. You can see the appeal in a cold cabin, where you have plenty of power but no drain field. Poof, ash. The trade-off? Energy consumption and heat management. Then we get to the modern bathroom arms race, the bidet seat. In the 1980s and onward, microcontrollers and solenoid valves found their way into toilet lids. And suddenly, you had heated seats, adjustable warm water sprays, oscillating and pulsing wash patterns, air dryers, night lights, auto lids, and deodorizers. Under the plastic are a handful of inventions that make it pleasant instead of terrifying. An instant water heater or mixing valve that keeps temperature steady, a retractable nozzle that self-rinses, a seat occupancy sensor, and a fan that either pushes air through a carbon filter or, more cleverly, draws air from the bowl rim and exhausts it into the drain stack, so smells never enter the room. Those odor extraction seats are a quiet revolution. Instead of trying to perfume the bathroom, they capture the air at the source and route it away. The ducting is small, the fan is whisper quiet, and with a check valve to keep sewer air from coming back. It's the spiritual descendant of Cumming's water seal. Different mechanism, same mission. No stink. And then there's the final boss, the space toilet. Gravity is the one engineer you can always count on, unless you leave the planet. In microgravity, waste doesn't fall, it floats. The solution? On the Space Shuttle, the International Space Station, and today's vehicles is controlled airflow. The bowl is really a seat with a gentle suction field that moves air from you to a separator. A rotating drum or cyclone strips solids from the airstream into a canister lined with a replaceable bag. Urine is captured through a funnel and hose, separated from air in a spinning separator and sent to processing. On the ISS, that urine is distilled and turned back into drinkable water. Solids? They're stored and eventually disposed of when a cargo vehicle burns up in the atmosphere. The details are full of delightful engineering. There's alignment training. Yes, astronauts practice to ensure a proper coupling to the airflow. There are foot restraints and thigh bars so you don't push yourself off the seat mid-mission. Valves are carefully sequenced to avoid pressure spikes. Filters prevent anything from escaping back into the cabin. Everything must be serviceable with gloves. What's the trap in space? It's the airflow system itself. Fans, ducts, separators, and valves create an invisible stream that replaces gravity. No water seal, no siphoning, just moving air doing the work. And because smell flows with air, the system doubles as odor control. When you zoom out, the connections are obvious. The S-trap used water to block air. Vent stacks used air to protect water. Siphon-jet bowls used geometry to make gravity do more with less. Vacuum systems used pressure gaps instead of water columns. Bidet seats and space toilets use fans and ducts to move both air and the story along. It's all variations on the same theme. Control the path, control the pressure, control the smell. A water seal changed everything. Cumming's curved trap turned a smelly novelty into a viable indoor appliance by blocking sewer gases with a little standing water. Quiet beats brute force. Siphon-jet bowls and tuned trapways use geometry and timing to flush better with less water and less noise. Venting is invisible but essential. Vent stacks and code-mandated traps keep water seals intact, preventing the chain reactions that once sucked traps dry. Different environments demands different physics. Vacuum toilets swap gravity for pressure. Composting and incinerating models solve for water and infrastructure limits. Space toilets reinvent the job with airflow. Comfort matters. From odor extraction seats to heated bidet sprays, modern patents focus on human experience as much as mechanics. Next time you hear that soft whoosh and nothing else, take a second to appreciate the quiet symphony under the lid. It's hundreds of years of problem solving aimed at one unglamorous goal: make waste go away without inviting it back. From Harington's early closet to the S-trap's water seal, from siphon jets and vent stacks to vacuum valves and orbital fans, it's the same battle fought with different tools. And it's a story that keeps going. Urban droughts push low flush designs even further. Airplanes and trains squeeze more reliability out of tiny valves. Off-grid cabins mix microbes and airflow to lighten their footprint. Bathrooms get smarter, cleaner, friendlier. Spacecraft keep chasing the perfect balance of privacy, physics, and plumbing in a place where water weighs a fortune and gravity's on sabbatical. It's easy to joke about toilets, and we should, because humor helps. But the truth is, they're among the most consequential machines ever engineered. They saved cities, they unlocked modern life, and they keep evolving, quietly, one patent at a time. All right, your turn. Back to that question from earlier. If you could lock in one innovation forever, what's your pick, and why? The classic S-trap that keeps the stink out? A silky smooth siphon-jet bowl? A vacuum flush that never clogs? A composting setup for off-grid freedom? A heated bidet seat with all the bells? Or the space toilet's airflow magic? Drop your choice and your reasoning in the comments. I can't wait to see which camp wins. And yes, this might be the most civilized debate we'll ever have.